Good morning, dear students. Welcome to another session of Verilog HDL. So in previous this thing, we actually started off with the discussion of behavioral modeling. So in behavioral modeling, we started off with the discussion relevant to the procedures, structured procedures. So before that, we understood that what is meant by behavioral level modeling. So it is in this case, what you do is you write the code in the form which is almost similar to your C programming kind of thing, but with a few changes which are specific to the hardware description language. That is what you try to do here. Now it is you have seen that in previous this thing we dealt with the gate level modeling, and then before that we had seen switch level modeling and other stuffs. So here and data flow modeling also we saw few examples. So we can see that as we go ahead, right, from lower level of abstraction to the higher level of abstraction. So behavioral level of modeling or behavioral modeling is the highest level of abstraction. So this provides coding which is very easy to go ahead. Since suppose if you have two languages, one is assembly level language and one is high level language. The preferred one for you would be high level language because it becomes easy to write the code. So both are having some pros and cons. So that will not be discussing over here. So behavioral level modeling is the highest level of abstraction. And in this level of abstraction, we write the code somewhat similar to the programming style, which we make use in C programming. So, but there are some special features related to the hardware description language, since we have to mimic the hardware capabilities. Now, for example, if I'm using a flip-flop, say, for example, I'm using a JK flip-flop. So in that J and K simultaneously, I'll be applying some values, say 0 and 1. So in a hardware, this thing, what happens is both the inputs are applied simultaneously. So it is like concurrent application of that input. So at the same time, you are applying the input. And at the output, you might be getting Q and Q bar at the similar time. That is concurrently you're getting those outputs. So such kind of behaviors should be uh, made available in your hardware description language. So these are some special features. What makes this different from your other, say, programming languages such as C and C++. So those things. So here we'll be dealing with those aspects. So behavioral level of modeling, highest level of abstraction, much easier way to code because much easier steps. No need to bother about the lower level of implementations. In gate level, if you remember, if you had to use a AND gate, so you should know what is the input to the AND gate, where it is going, what is the output, whether it is going to other gates or whether it is directly connected to the output. So those all things you should be knowing, and based on that, you should be instantiating the gates. So in gate level modeling and data flow modeling, slightly upper version. So wherein you directly specified what is input, what is output, and what has to be done using the operators. For example, logical operators you implemented that, but you are not bothering about how that is actually internally being done. Now here we'll be going a little bit further. So in this one, basically the implementation will be dealing with algorithmic style of programming. So you have the algorithm. That algorithm should be, I mean, you'll be framing the algorithm, and using that you will be trying to achieve what is intended. For example, you want to achieve, say, a adder. So you know that the two inputs are there, A and B, and then Cin is there, and two outputs, sum and Cout. So algorithmically, you try to implement these things using different techniques, such as you can use, say, the if statements, else statements, case. Then you can go for looping constructs. So dependingly how you want, what is the implementation and how you want to go ahead. So that is what you're looking out. And apart from that, you can use the say operators what we have discussed in data flow modeling. We can use those also over here. So behavioral level of modeling is pertaining to all these aspects. So in that, the first thing which comes is the structured program, structured procedures. So in that we have two this thing, that is one is always and another one is initial. These are the two structured procedure statements which are present in Verilog. Now, what does the name itself tells that it has it has something to do with regularly executing something, and this one only once, only at the starting. So something of this kind we can just make out from the names of these keywords. Now, another one thing to note down is Verilog is concurrent programming language, whereas C programming is sequential. That is, if I write statements, right, then in C programming, how they are executed. So if I write statements in C programming, for example, I write it as int x, then I write it as int y. So then here I can have z. So what happens is in sequential, this is the first statement. So in that first variable, so this will be executed. This is the second statement. This statement is executed in that this is the first variable in this one. So this one gets executed. And next is this one. So one after the other will be executed. Whereas this is not the case in Verilog, but we can have some control structures in order to avoid these things. So there, if you are writing some variables like x is equal to 1, y is equal to 1 on different lines you are specifying, say it may be a reg type or any data type which is there. So if you're writing this in, if nothing is specified, so what happens is these two are executed simultaneously. So that is in parallel. So this is called concurrency. So concurrently both get executed. So when such kind of behavior is there, some changes in the execution way has to be observed. So if I want to test what is the Z value, if I utilize some expression, so what will be the result of Z? So in concurrent, we have to analyze these things. So it is not the regular analysis what we have to look out for. So it will be having slight differences. Okay, so those all things we have to check out. So those all we'll be discussing in this part. So the execution will be concurrent. Therefore, Verilog is termed as concurrent programming language. But we can make a few things sequential under this. We can make Verilog to act as a sequential execution with some constraints over there. So that is what we can look out for. Okay. So here we have the first this thing, that is initial statement. So the name itself tells that what all statements fall within this initial statement will be forming the initial block. So statements within the initial statement will form the entire initial block. Initial is a keyword. Initial is a keyword in Verilog. So which helps us to identify that if the statements which are present in this initial block will be executed only once. They'll be executed only once. And generally it will be executed at time t is equal to 0. That is at the 0th simulation time. It will be executed. Now you can have more than one initial block in your Verilog. So you can have multiple initial blocks. Then, and if nothing is specified, all actually start concurrent execution. All will be executed at time t is equal to 0. That is 0 is the time unit which is specific to that simulation what you are looking at. Then here, if we have multiple statements, so as it is specified that all the statements inside the initial statement constitute the initial block. So initial block can have single statement or it can have more than one statement. When it is having only single statement, right? So no need to use begin and end keywords. That is, these two keywords are not necessary. You can use it, but it is not required if only one statement is present within the initial block. If multiple statements are there, if I have to club them and I have to identify that these all belong to one initial block, then I have to make use of the keywords begin and end. So that is what I have to utilize. So this will check out here. So here we have module stimulus, some say data types are being declared here. Now you have used a keyword initial. The keyword initial is being utilized. So in this initial, you can see that there is no begin and end. There is no begin and end. But here what you're doing, m is assigned with a bit value of 0. I hope you remember what does this imply. So this implies that the size of the data, that it is 1 bit. This apostrophe with the b, that is it represents the data type. So here it is, sorry, not data type, it represents the data format. So it is in bits, it is in binary, it is in binary, and this one represents the value. This one represents the value. Okay. So since it is only 1 bit, it can be either 0 or 1. In this case, m is assigned with the value of 0. That is logical 0, or bit 0 is assigned to m. So this is just a single statement. So if it is single statement, no need of begin and end, and this statement belongs to this initial block. Now here we can see that inside the same this thing, I have another initial block. So this block and this block both start the execution at time t is equal to 0. That is at 0 time unit, both will start the execution. Now here you can see that there is begin and end keyword which are being utilized. So here we have a is assigned with bit 1, b is assigned with bit 0. So there are two statements which are present in this case. So these two statements are pertaining to this block, this initial block. So if I have to specify that, then I have to make use of the keyword begin and end. So these two have to be utilized. So this gives an indication that these two statements belong to this and this entire initial block. So here we have just two statements which are present. Now here also you can see that there is another initial block, there is another initial block, and this is the delay what we have specified. If you remember, these are the delays. So after 50 time this thing, this stops, this finishes. So this is how it goes around with the initial block. So statements falling within the initial blocks constitute the entire within the initial statement constitute the entire initial block. There can be only single initial. There can be only single statement within the initial block, or there can be multiple statements within the block. When there are multiple, you should use the keywords begin and end to club all the multiple statements. So here, if I just look at the execution time, if I look at the execution time, right? So you can see how it starts off with the execution. So here, since all are concurrent, right? All the initial blocks start at time unit t is equal to 0. All start at the same time. Now here we see that in the first one, there is no any hash delay specified. There is no any hash delay. So when this starts off at time t is equal to 0, m gets assigned with the value of 0. So at time t is equal to 0, m gets assigned with 0. That is, this statement gets executed. Now here in the next initial block, if you just see, it is 5 and 25. So here if I just see, so at 5 time unit, this statement will be executed. That is, a is equal to this one at 25 time units. So if I just observe, so what is happening is since it is this statement is following this one, right? So what happens is the statement follows this statement is what happens is after 5 time units, right? After that plus 25. So at 30th time unit, these statements get executed. So here we can see that at 30 time units, this statement is getting executed. That is, b is equal to 0. So this statement is getting executed. Now, if I come to this one, right, this also starts at time t is equal to 0. Time t is equal to 0. So when this one starts at time t is equal to 0, after 10 units of delay, 10 time units of delay, this statement will be executed. And next statement will be executed after 25 plus 10, that is after 35 time units. So if I just happen to see here at 10 time units, you have x is equal to 0 that has been executed. Now 10 plus how much? 10 plus 25, that is 35. After 35 time units, if you just observe, we have y statement being executed. So you can see that all the initial blocks start their execution at time t is equal to 0. So that is what is happening in this case. Now this initial block also starts its execution at time t is equal to 0. So here a delay of 50, this thing is specified. So what it implies is if it is 0 after 50 time units, the finish task will be executed. The finish task will be executed. So that is what is happening. So here after 50 time units from 0, finish task will be executed. So this is how it goes around with initial block. Okay, next is the always statement. The name itself tells that uh, these statements have to be executed again and again. That is always. So till some condition you want to satisfy, you can satisfy, or say some task is executed, you can go ahead in that form. So always is the keyword which is utilized to identify the always block, and there can be a number of statements within the always block. There can be single statement, there can be multiple statements as as is the case even in the initial statement. So all the statements which fall under the always statement constitute the always block. So you have the always block. So even in this case, right, the always statement starts at time t is equal to 0. That is at 0 time unit. All the blocks. There can be multiple always blocks present in a module. There can be multiple always blocks present in a module. So, but what is the special feature of this one is which differentiates this from the initial block is this one will be repeatedly executed. This one will be repeatedly executed, but initial block statements won't be executed multiple times. It will be executed only once. It will be executed only once. So this is the difference between the two. Now here, let us look through an example. So here we can see that there is a module which is being defined, and there is a variable which has been defined over here. So this is initial. So initial will be executed only once. Only one statement is there in this case. Only once this initial block will be executed. So in which what is happening? Clock is being assigned with the value of 0 at time 0th time unit. At 0th time unit, this gets executed. Now, another thing, what happens is this initial block starts its execution at 0th time unit. This always block also starts its execution at 0th time unit. Now, in this always block, you can see that there is only one statement. What it is pertaining to, it is pertaining to clock is negation of the clock. So its value gets toggled. So if it was 0 previously, it becomes 1. If it was 1 previously, it becomes 0. So this keeps on repeating. Now here you can see that there is a delay which has been specified, that is #10. So what happens is, so 0, this thing always statement gets executed, but there is a delay over here. So this statement gets executed only after 10 time units. So at 10th time unit, the clock, so if it was 0, it becomes 1. So again, after 10 time units, it becomes 0. So this will be executed again and again. So it will be like you have a clock 0, then after 10 time units, it will be 1. So after 10 time units, again, it will be 0. So what is happening? You are generating the clock over here. So here, if you just observe what is happening, this is 10, this is 10 time units. So from here to here, it is 10 time units. So in total, if you just see what is the time period from this point to this point, it is, in our case, here it is equal to 20 time units. It is equal to 20 time units. So this is what is happening in these this always block. So you are generating a clock which is having a frequency of say 20 time units, 20 time minutes, because it is toggling its condition for every 10th time unit delay, because that delay is being specified here. Okay. So this is what is happening in this case. And there is another one initial block in which only one statement is there, and that is after 1000 time units, you execute the task of finish. So this also starts at time t is equal to 0. This also starts at time t is equal to 0. This also starts at time t is equal to 0. So at time t is equal to 0, clock is assigned with 0. And after every 10 time minutes, this is continued. This will be continuing up to the 1000th time unit, because at 1000, this statement gets executed. That is 0 plus 1000 statement, finished task will be executed. So this is what is happening. And this is how you're generating the clock in this case. So time period is 20 time units, what he has specified over here. So this is how always block works around. Okay. So the same this thing they have discussed over here.